So we're in section 5.8, and we're talking about probability. And it may seem a little strange to talk about probability in a unit where we're talking about area, but we'll talk about why that is in just a second. So let's do a quick review on probability and how we figure out probability. What we're talking about here is what we call theoretical probability, which means that it's not based on an experiment. We're not counting coin tosses. We're not counting anything. We're not measuring anything. It's based on what we know about the numbers that are involved. But usually we just call it probability. And we calculate it by figuring out the favorable outcomes divided by the total outcomes. And we come up with these numbers depending on what our situation is. And when we calculate probability, we always get a number between 0 and 1. So we either get a fraction or a decimal, and sometimes we'll turn that into a percent, but it's always between 0 and 1, or 0% and 100%. Probability of 1 equals that whatever we're talking about is certain to happen, and a probability of 0 means it's impossible. So this is how we figure out probability and what we come up with. Let's do a quick example problem with probability, and then we'll talk about what it has to do with geometry and with area. So we have some kind of container with 20 marbles. And we have 5 red, 5 blue, and 10 white. And we want to figure out the probability, and usually what we write is just a capital P for probability, of picking out a red marble. So in this container we have 20 marbles. We want to figure out the probability of picking out a red. So how many favorable outcomes do we have? 5. And how many total outcomes do we have? 20 possibilities. So that turns into, if I reduce this, 1/4, or I could write that as 0.25, or 25%. So the probability of reaching into that container and picking out a red marble is 25%. How about the probability of picking out a blue marble? It's the same, right? We have 5 out of 20. Same thing. So we can write that's 25% also. How about the probability of a white? 10 out of 20, which is 1/2, or 50%. We have a 50% chance of picking out a white marble. So that's how we figure out probability in a situation like this. Favorable outcomes divided by the total outcomes. Turn it into a fraction or a percentage or a decimal. So let's see what this has to do with geometry. What if we have a situation like this? So we have these two circles. The radius of this circle is 5, and the radius of this circle is 2. And we want the probability that if we throw a dart at random, that it hits the small circle. So we want to figure out what are the chances that if we throw a dart at this target at random, that it lands in the small circle. Anybody have an idea of how we would figure that out? We need to know, it has to do with the area. So the probability is related to the areas. So in this case, when I have shapes and I'm interested in the probability of something landing in a particular shape, it has to do with the area. So in this case, and this is the formula that you want to have in your flip book, that when we have shapes, that the probability equals the favorable area over the total area. So our favorable outcome is the area of the place that we want to hit. And our total outcomes is the total area of the whole shape. So let's calculate our probability in this case. And this, again, this is what you want to have in your flip book to help you remember. Favorable area over total area. So for our problem, the probability is the favorable area is the area of the small circle. So how do we find the area of that small circle? How do we find the area of a circle? Pi r squared. So pi times 2 squared. And the total area, pi times 5 squared. What happens to the pi's? They cancel out. Pi divided by pi is just 1. So we get that the probability is 4 over 25. And if we write that as a decimal, that's 0.16 or 16%. So if we threw a dart at this target, this round target, there's a 16% chance that the dart would hit the small circle. That's another way of saying that that small circle is 16% of the area of the large circle. We're just comparing their areas. Any questions on that? So let's look at one more example, and then we'll be done for today. So this time we have rectangles. And we want the probability that a dart hits a small rectangle. And let's put some units on here. This side is 12, this side is 4, this side is 2, and this side is 6. So the probability, what is the favorable area? Which one is the favorable area? We're trying to hit the small rectangle. So the favorable area is 2 times 6. And the total area, 12 times 4. So we get 12 divided by 48, which is 1 over 4, or 25%. So if we threw a dart at this rectangle, we'd have a 25% chance of hitting this small rectangle if we're throwing the dart at random. Any questions on geometric probability? So the idea of geometric probability is pretty straightforward. The trick comes with finding the areas. Sometimes finding the areas can be a little tricky, depending on how the problem is set up. But the idea is we take the favorable area and divide by the total area, and that's what we have to do for geometric probability. All right.